There are stars out there that shouldn't exist. The James Webb Space Telescope has just captured something extraordinary. Ancient stars. Too bright. Too heavy. Too early. According to everything we know, they shouldn't be there. Unless the universe has lived this life before. This is the story of impossible stars, and the disturbing idea that our universe might be recycled. Chapter 1. The stars that defy cosmic history. The Big Bang, the beginning of everything, was supposed to happen 13.8 billion years ago. That's the story we've been told. One singular explosion, a blinding burst of energy, a cosmic birth. Then came chaos. In the first few 100 million years, the universe was not a place you'd recognize. It was hot, dense, wild, a violent sea of charged particles, radiation, and expanding space. According to our best models, nothing resembling a star could have existed back then. It was simply too early. The universe hadn't cooled down enough. Atoms hadn't even fully formed. Light couldn't travel freely. It was a time before transparency, before complexity, before structure. And yet something doesn't add up. The James Webb Space Telescope, the most powerful eye we've ever pointed into the dark, has started sending back images, not just of nearby galaxies or stars in our cosmic backyard, but of the ancient universe, the deep, early universe, so far away that we're looking back in time itself. And what it saw changed everything. It found stars, not just any stars, ancient, enormous, heavy stars that shouldn't exist. They were shining bright and complete just 300 million years after the Big Bang. By comparison, that's like watching a toddler graduate college. It's not just unexpected, it's impossible, or at least it should be. To understand how strange this is, we need to look at how stars actually form. In the modern universe, stars are born from clouds of gas and dust slowly collapsing under gravity. It's a slow, delicate process. Even under ideal conditions, it takes millions of years. But in the early universe, nothing was ideal. There wasn't enough time for matter to settle, cool, and coalesce. And there definitely wasn't enough time for multiple generations of stars to live and die, to seed space with the heavy elements needed for bigger, more complex stars. Yet the stars that Webb found were massive, full of elements like carbon, oxygen, and iron. These elements don't exist naturally in the aftermath of the Big Bang. They're forged inside stars and released when those stars explode. So the stars Webb detected couldn't have been the first ones. Others had to come before. But how? There wasn't enough time. It's as if we walked into a theater expecting to see the opening act, only to find the finale already on stage. We missed something, or something is wrong. Some scientists have argued that we're simply misinterpreting the data. Maybe what we're seeing are optical illusions, gravitational lensing, distorted light, or unknown factors skewing the results. That's possible. And in science, skepticism is healthy. Extraordinary claims demand extraordinary evidence. But Webb's instruments are incredibly precise. Its data has been double-checked, triple-checked, and these stars keep showing up, not once, not twice, but again and again. They exist in galaxies that look far too evolved for their age. Galaxies with structure, with spiral arms, with supermassive black holes at their centers. These aren't baby galaxies. They're grown-ups hiding in a universe that should still be in its infancy. If this is a mistake, it's a widespread one. If it's real, then something is fundamentally off with our understanding of time, formation, and maybe even the origin of the cosmos itself. Think about what that means. If these stars are real, if they really did form just a few 100 million years after the Big Bang, then the timeline we've constructed for the universe is broken. It suggests that structure appeared much earlier than it should have. That matter coalesced faster. That complexity didn't wait billions of years to evolve. It jumped ahead, somehow. But how? What force? What condition could have accelerated the birth of galaxies and stars? One possibility is that the early universe behaved differently than we thought. Maybe there were quantum effects, unknown particles, or extra dimensions that sped things up. Or maybe, just maybe, this isn't the first time the universe has done this. Maybe it wasn't born 13.8 billion years ago. Maybe it was reborn. Some physicists are starting to consider theories that challenge the entire Big Bang model, not to erase it, but to expand it. The idea that our universe is part of a cycle, that it's exploded before, collapsed, reformed, over and over again. In such a model, relics from previous cycles could survive. Structures might persist. Information might carry over. Could these impossible stars be leftovers from a past iteration? Could they be echoes of a universe that existed before our own? It's a radical thought. But then again, so is everything about the cosmos. From the beginning, we've built our models based on what we can see. But what if the truth lies in what we can't? What if our cosmic history is incomplete not because it's wrong, but because it's only one chapter in a much larger story? The James Webb Space Telescope has given us a glimpse into that mystery. And in doing so, it may have cracked open a door we didn't even know existed. A door that leads backward not just in time, but into something deeper. A hidden structure beneath the story we thought we knew. A cosmic memory written in starlight. These stars aren't just distant points of light. They are questions. Ancient, burning questions that challenge our timeline, our physics, and even our place in the universe. We thought we understood how everything began, but the further we look, the more we find that something doesn't fit. These stars shouldn't be here. They don't belong in this version of the timeline, and yet, there they are, shining, waiting, refusing to be ignored. Maybe they're telling us something, or maybe they're just reminders that the universe is bigger, older, and more mysterious than we can possibly imagine. That even after billions of years, it still knows how to surprise us. And that the story of everything might be far from over. Chapter 2. Data nobody wanted to believe. The James Webb Space Telescope didn't just find one strange object. It found many. A growing list of galaxies and stars that simply don't belong in the early universe. These weren't faint glimmers or half-formed clouds of gas. They were fully developed systems, large, structured, complex. Some of them rival the mass and size of our own Milky Way, but they appeared far too early, just a few 100 million years after the Big Bang. According to our best models, this shouldn't be possible. Galaxies are supposed to take time. Lots of time. Billions of years. First, clouds of hydrogen collapse under gravity. Then small stars ignite. Some of those stars explode, scattering heavier elements into space. Those elements become the building blocks of larger, more complex stars, and eventually, planets. It's a long, slow process, But the galaxies that Webb observed had already skipped several steps. They were full of heavy elements, carbon, oxygen, iron, all of which can only be created inside stars. Stars that must live, die, and explode in order to spread those materials. That cycle takes hundreds of millions of years at minimum. And yet, somehow, these ancient galaxies had already completed that cycle. Not once, but multiple times. This is where things get uncomfortable, because the data doesn't just suggest early structure, it demands a new explanation. The physics we know tells us that time is required to build complexity. But this data implies complexity was already there, fully formed, in place, ready. That's not just inconvenient, it's unsettling. Scientists around the world were cautious at first. Maybe it was an error, a glitch. Maybe the redshifts were being miscalculated. Redshift is how we estimate distance and age in deep space. If a galaxy's light is stretched more than we expect, it appears older. Maybe these galaxies weren't as old as they seemed, but the measurements held up. They were reviewed, recalibrated, and confirmed, and more galaxies kept showing up, each one telling the same impossible story. It's not just the timing that's strange. It's the density. These galaxies are incredibly compact, tightly packed with stars, far denser than galaxies in the modern universe. That alone breaks expectations. In our current model, galaxies grow through mergers. Small ones collide, combine, and gradually form larger systems. It's a chaotic, drawn-out process. But these galaxies didn't follow that rule. They seem to have skipped the queue, forming big and dense right out of the gate. Some scientists are calling them cosmic monsters. Others are simply stunned. Because if these galaxies formed this fast, it means something in the early universe worked very differently than we thought. And that's not a small adjustment. It's a full-scale revision of how we understand the birth of everything. The challenge is explaining how these galaxies got their metals. In astronomy, metals doesn't just mean things like iron or gold. It means any element heavier than helium. These are created in stars and released through supernova explosions. So if we see lots of metals, we know lots of stars have lived and died already. But how could that happen so early? There wasn't supposed to be enough time. And yet, here they are. Galaxies full of second and third generation stars. As if the universe hit fast forward in its first few 100 million years. The timeline doesn't fit. The chemistry doesn't fit. The structure doesn't fit. This is why many researchers were hesitant to speak up at first. The implications are massive. If Webb's data is correct, it means we've misunderstood one of the most fundamental chapters of the universe's history. Not slightly, completely. And yet, science doesn't move by belief, it moves by evidence. The evidence, so far, is consistent. These galaxies are too old, too big, too metal-rich, and too early. Each one is a silent contradiction, floating in the deep past, daring us to explain it. There are a few theories trying to make sense of this. One idea is that the early universe had special conditions, more dense regions, faster cooling, or unknown forces that triggered rapid star formation. Another theory suggests that dark matter might have played a larger role, helping galaxies form faster by pulling material together more efficiently. But none of these theories fully explain the sheer number and maturity of these galaxies. Some physicists have even proposed more exotic ideas that perhaps the constants of nature were different in the early universe, or that time itself flowed differently. But such ideas are controversial and hard to test. Then there's the possibility no one wants to entertain, at least not out loud. What if these galaxies weren't part of this universe's beginning at all? What if they came from something older? Something that survived before the Big Bang, or carried through it in ways we don't understand? That suggestion, while speculative, is growing harder to ignore, because the data keeps stacking up, and the anomalies are becoming too many to dismiss. Webb was designed to see further and deeper than any telescope before it, and in doing so, it may have uncovered more than just distant light. It may have uncovered cracks in our story. We once believed the night sky was unchanging, that Earth was the center of the cosmos, that light always traveled in straight lines. We were wrong about all of those. So maybe we're wrong again. Maybe the early universe isn't what we thought it was. Maybe it never was. What's especially haunting is how quiet the universe is about all this. These galaxies don't scream for attention. They just exist. Silent, distant, impossible. Their very presence is a challenge, a cosmic riddle. They force us to ask the question we don't want to ask. What if we missed something fundamental? What if the story we've written about the universe, its birth, its growth, its laws, is only part of the truth? Or worse, what if it's not the first version of that story? For now, all we have is data. Webb keeps sending it back. More galaxies, more stars, more questions, and the deeper we look, the stranger it gets. Scientists continue to publish papers, to run simulations, to test new models. But the sense of unease is real. This isn't just about stars or galaxies. It's about time, about origins, about what we think we know. The stars that shouldn't exist are telling us something. They don't fit our equations. They don't wait for our theories. They simply shine quiet reminders that the universe is under no obligation to make sense. And maybe that's the point. Chapter 3. The Theory of a Recycling Universe. For most of modern science, the universe had a clear origin, the Big Bang, one single explosion, 13.8 billion years ago. That gave rise to time, space, and everything we know. It expanded, cooled, and slowly evolved into the cosmos we see today. But what if that story is incomplete? What if the Big Bang wasn't the beginning? What if it wasn't even unique? Enter Roger Penrose, one of the most respected physicists of our time, a Nobel laureate with a long history of challenging conventional ideas. He proposed something bold, something unsettling, a theory known as conformal cyclic cosmology. It suggests that the universe doesn't have a single beginning or an ultimate end. Instead, it resets, over and over again. A cosmic cycle that stretches beyond imagination. Each Big Bang is not a true beginning, but a bridge between two cosmic epochs. According to this idea, our universe is just the latest in a series of eons. Entire universes have come before ours. Entire universes may come after. In Penrose's model, the universe expands forever. Galaxies drift apart. Stars burn out, and eventually, all that remains are black holes and cold radiation. Then, in the far future, even black holes evaporate through Hawking radiation, and the universe becomes a thin soup of particles. At this stage, space loses its sense of scale. There's no mass, no structure, just uniform emptiness. And in that emptiness, something strange happens. Time and space become meaningless. From that near-zero state, a new Big Bang can occur. A new eon begins. A new universe is born, not from a singular explosion of everything from nothing, but as a transformation from the ashes of the last. It's not reincarnation in the spiritual sense. It's a physical, mathematical rebirth. A transfer of geometry, not matter. Penrose believes that certain patterns, certain imprints can survive. The transition from one universe to the next. They don't carry stars or galaxies, but they may leave behind traces, faint memories. He calls these Hawking points, hotspots in the cosmic, microwave background that could represent the final death throes of black holes from the previous universe. If they exist, they would be the fingerprints of another eon, burned into the sky of ours. This theory is not just poetic, it's predictive. Penrose and his colleagues have claimed to identify possible Hawking points in real data. Not many, but enough to raise eyebrows. They appear as tiny circles in the background. Radiation of our universe colder or hotter than the space around them. Not random noise, not explained by inflation. Just there, sitting quietly, waiting to be understood. If they are real, they might be evidence that something from before the Big Bang made it through. A trace, a scar, a whisper. But this raises uncomfortable questions. If universes recycle, what survives the cycle? Could information pass from one to the next? Could some kind of structure or order make it through? Or something more? Penrose argues that while most matter and structure are erased during the transformation, the underlying geometry can remain, meaning some shapes, some patterns of space itself might repeat. We might be living inside a cosmic echo, a familiar rhythm, a pulse. And if the universe has done this before, how many times? 5, 100, infinite. There's no known limit. Each eon could be radically different or eerily similar. Maybe some fundamental constants shift. Maybe life evolves again and again, unaware it's playing out a scene that has happened before. Maybe we are the first of our kind, or maybe we are not. One of the most haunting aspects of this theory is that it offers no clear beginning, no singular origin, no before that matters. In conformal cyclic cosmology, there's no edge to time, just layers. We are one in a chain, one ring in an infinite spiral. That means the mystery of why the universe exists may not be solved by going backward, because backward just loops around again. There is no first spark, only eternal repetition. The implications stretch beyond physics. They touch philosophy, identity, even fate. If the universe resets forever, does history repeat? Do patterns return? Is there cosmic memory embedded in the laws of nature? Some scientists scoff at these ideas. They say Penrose's model is elegant but speculative, that the data is inconclusive, that more evidence is needed. And they're right. Extraordinary ideas demand extraordinary proof. But others argue that Webb's recent discoveries may breathe new life into this theory. Galaxies forming too early, stars too evolved, structures too complex for the timeline. Maybe the reason things appear too old is because they are. Maybe they're not just from our universe, but from the tail end of a previous one. Maybe some deep structure, some cosmic seed carried through the reset. Not matter, not light, but shape, design, instruction. The idea is hard to digest, but so was the Big Bang once. There was a time we couldn't accept that the universe had a beginning. Now we must consider it might not have had just one. What's beautiful about Penrose's theory is its simplicity. It doesn't rely on extra dimensions, parallel universes, or invisible strings. Just geometry, just the way space itself curves and stretches. And in that simplicity lies something terrifying. Because if he's right, then the universe is more than old. It's eternal. And if it's eternal, then somewhere, sometime, this moment might happen again. Not exactly, not identically, but close enough to feel familiar. Close enough to question the arrow of time. Close enough to wonder if your thoughts, your choices, your life, are part of something that's already played out before. Penrose doesn't claim to know all the answers. No one does. But his theory gives us a new framework, a way to interpret what we're seeing through telescopes like Webb, a new lens to examine the anomalies we keep discovering. And maybe, just maybe, it brings us one step closer to understanding why the stars we see today don't fit into the story we've written. Because maybe the story is older than we thought. Much older. In the end, conformal cyclic cosmology reminds us of one simple truth. The universe is not obligated to make sense. It doesn't have to follow our expectations. And sometimes, the most unsettling explanations are the ones that fit best. The idea that the cosmos resets again and again may sound strange, but so does the idea of time itself having a beginning, of everything we see coming from a single flash. Maybe the real question isn't whether the universe has cycled before. Maybe the question is, how many times has it already happened? And how many more are still to come? Chapter 4. Ghosts from the Universe Before. Could these ancient stars be more than just anomalies? Could they be something older? Something stranger, relics from a universe that existed before our own? It sounds like science fiction, but some of the most respected physicists in the world are taking this idea seriously. Among them is Sir Roger Penrose, the same man who proposed conformal cyclic cosmology, the theory that the universe doesn't begin and end, but rather cycles endlessly through phases. According to Penrose, there may be actual evidence that something from a previous cosmic cycle survived the transition into our current one. He points to patterns, peculiar shapes embedded in the faint afterglow of the Big Bang, known as the cosmic microwave background. This glow is like a fossil, a preserved snapshot of the universe, when it was just 380,000 years old. Most of it looks like random noise, the soft static of the early cosmos cooling down. But some regions aren't random at all. Penrose noticed a series of strange, perfectly circular spots, small, cold rings scattered across the sky. To the untrained eye, they mean nothing, but to someone who understands the physics of the early universe, they are out of place. These circles don't match what inflation theory predicts. They don't align with normal fluctuations of temperature and density. They stand apart, uniform, symmetrical, and eerily clean. Penrose believes they are not accidents. He believes they are the scars of collisions between supermassive black holes in a previous universe. Black holes so massive, their final moments would have released unimaginable energy. And when that universe ended, when it reached its smooth, empty state, those collisions left a mark, a kind of fingerprint, a signature in space itself. When the new cycle began, when our universe was born, that signature remained. Think of it like rings in a tree. The outer bark might be new, but the pattern within carries the memory of everything that came before. In this case, the rings are in the fabric of the sky, quiet echoes, ghosts. If Penrose is right, we are not the first observers to look up and wonder where it all began. We are not the first minds to emerge from stardust, and we may not be the last. These cold spots, these possible Hawking points, named after the great Stephen Hawking, would be direct evidence that black holes in a previous universe evaporated and left their imprint across eons. In other words, some parts of the past may not be truly gone. They may be etched into the foundation of the cosmos. The idea is as beautiful as it is unsettling, because it implies that our universe was born not from nothing, but from something vast, strange, and ancient. It also suggests that the early conditions of our cosmos were not entirely random, that structure, geometry, energy, maybe even information could be carried over from cycle to cycle. That raises a profound question. What else could survive? We tend to think of the Big Bang as a clean slate, a reset button. But if certain black holes can leave marks in the next universe, what about other things? Could particles survive the transition? Could patterns of motion? Could complex structures on any scale persist across the Great Divide? We don't know. But Webb's observations have reopened this door. The stars and galaxies it sees are not only older than expected, they may be acting like things that have already lived once before. Their maturity, their mass, their structure, it all points toward a kind of preconditioning. It's as if the cosmos began with a head start, and that head start may not be a mistake. It may be a memory, not a conscious one, but a physical memory embedded in the laws of space itself. The strange circles in the background radiation are not the only clues. Some researchers have noted unusual alignments in the way galaxies are distributed across the sky. Others point to curious anisotropies, irregularities in the radiation map. Most of these can be explained by chance, by normal variation, but not all. Some persist. Some remain stubborn. And when multiple anomalies stack together, a new narrative starts to take shape. That's where the idea of ghosts comes in, not in a supernatural sense, but in a cosmological one. Ghosts of past universes, of dead black holes, of cosmic events so massive, they rippled through the very frame of reality and kept going. Even after the reset, these ghosts don't haunt us. They don't whisper or warn. They just exist, quiet, faint, distant, but undeniable. Their silence is more powerful than noise, because if we see them and we know what they are, then we also know something else. We are not witnessing the first universe. We're living in the shadow of something older, something that once burned bright, collapsed, and gave rise to everything we know. What's remarkable is how fragile this evidence is. A few temperature rings, a few data points, the delicate residue of a cosmic furnace now gone. And yet, this is often how great discoveries begin, with small, inconvenient details that don't go away. The scientific community is divided. Some call Penrose's ideas brilliant, others call them speculative, and he agrees more data is needed, more observations, more time. But the conversation has started, and it's not going away. The question we must ask is this: if something from before our universe still lingers, what else might have crossed over? Could the laws of physics themselves be shaped by earlier universes? Could time flow the way it does because it always has? Could the arrow of entropy, of increasing disorder, be inherited from cycles we can't even see? The implications stretch far beyond telescopes and temperature maps. They reach into philosophy, meaning, and identity. If we are the product of a recycled cosmos, then our place in the universe is not at the beginning, but somewhere in the middle of a long, looping tale. And maybe, just maybe, some trace of us will make it into the next round. Maybe long after our stars fade, after our galaxies scatter, after our black holes vanish, something will remain. Not our words, not our cities, but some shape, some vibration, some quiet mark in the background sky of the universe to come, like a whisper, like a scar, like a ghost. Chapter 5: The Black Hole Mystery. Among the most terrifying objects in the known universe are black holes, regions of space, where gravity becomes so intense that not even light can escape. We understand how they form. We know that when a massive star dies, its core collapses into a point of infinite density. Over millions or billions of years, these remnants can grow by consuming nearby matter, gas, dust, even entire stars. It's a process that takes time. But then came the James Webb Space Telescope, and what it found defies everything we thought we knew. Webb observed supermassive black holes in galaxies that existed just 500 million years after the Big Bang. These were not tiny stellar remnants. They were monsters, millions, sometimes billions, of times the mass of our sun, and they had no business being there. According to standard models, there simply wasn't enough time for them to form. Not in this universe. Not under the rules we know. The problem is one of growth. For a black hole to reach that size, it needs to eat a lot. And it needs to do so steadily, over an extended period of time. But the early universe was chaotic, dense, hot, and full of violent radiation. Conditions were not ideal for smooth feeding. Gas would have been scattered, galaxies still forming, matter not yet structured. And yet, these black holes weren't just present, they were fully developed, anchoring massive galaxies, regulating star formation, shaping the architecture of the early cosmos. It's as if they skipped the entire growth phase, as if they were born large, born old. This has forced scientists to consider alternative explanations. One possibility is that these black holes didn't start small. Maybe they formed directly from collapsing clouds of primordial gas, no star required. This would allow them to begin their lives with tens of thousands of solar masses. But even that doesn't fully explain how they reached such extreme sizes in such little time. The math still struggles to close the gap. Others suggest the existence of exotic, physics unknown processes that accelerated black hole growth. Or perhaps early black holes merged at an extraordinary rate, compounding their mass quickly. But there's a more radical idea, one that fits disturbingly well with what we're beginning to see across the early universe. What if these black holes didn't form here at all? What if they came from somewhere else? If the universe is cyclical, if it truly resets, as Roger Penrose and others suggest, then maybe some structures survived the transition, not intact, but in form, in influence. Perhaps black holes from a previous eon, unimaginably massive and ancient, collapsed at the end of their universe, only to seed the beginning of ours. Maybe their cores persisted in some hidden state. Maybe the very fabric of space remembered their presence. And when our universe began, they re-emerged not as new, but as echoes, carried over, recycled, reborn. It's not as outlandish as it sounds. Black holes are strange. They don't obey the same rules as stars or planets. They bend space-time. They hold information we don't understand. And according to some theories, they might even act as bridges between cosmic epochs. Stephen Hawking once suggested that information is never truly lost in a black hole. It's stored, encoded in subtle ways. If that's true, then black holes could function as vaults, repositories of data, structure, and geometry across universes. And if something passes through the end of one universe and into the birth of the next, black holes are likely suspects. These ancient giants we see today may be more than just relics of our universe's early years. They may be survivors. Their very existence hints at something older than the Big Bang, something that preceded it, something that endured. In this view, they're not just cosmic predators. They're messengers, silent observers drifting across cosmic cycles. And they're not alone. Webb's data suggests that wherever we look in the early universe, these supermassive black holes are already in place, already dominant, already shaping reality. It's almost as if they were waiting. This idea reframes our understanding of cosmic history. We've always assumed that black holes are consequences, results of matter, collapsing under gravity. But what if they are also causes? What if they're catalysts setting the tone for how galaxies form, how stars ignite, how time unfolds? In a cyclic universe, the roles reverse. The end becomes the beginning, and black holes, instead of being the final stage of evolution, become seeds for the next chapter. This also helps explain a mystery about black holes in general, why they're so uniform. Across the cosmos, no matter where we find them, they obey the same laws. They seem to appear in galaxies of all sizes and ages, as if drawn from a universal template. If black holes are inherited from a previous universe, that template might be older than our reality. There's another layer to this. Some physicists believe that black holes could warp space in ways that allow them to connect different points in time or even different universes. These theoretical pathways are called what? They remain speculative, unproven. But in the context of recycled universes, they take on new meaning. What if black holes don't just remember the past, but connect to it? What if, deep within their horizons, there lies not a singularity, but a doorway, a bridge between eons? It's a chilling thought, because it suggests that something might persist not just in mass, but in knowledge, in pattern, in memory. We don't yet know what black holes truly are. They defy measurement. They hide behind event horizons, boundaries beyond which no signal can escape. But we know they're real, and we now know they were present at the universe's earliest moments. Larger than expected, older than expected, more powerful than expected. That alone demands a new perspective. Maybe we've misunderstood their role. Maybe we've been looking at them backward, seeing them as cosmic ends, when in truth, they may be beginnings. The Webb telescope will continue to search. It will find more black holes, more galaxies, more contradictions, and with every discovery, our models will bend, our stories will shift, but the presence of these ancient giants will remain silent, immutable, waiting at the edges of understanding, watching from the far corners of space. They are not errors. They are not mistakes. They are keys, and perhaps one day we'll learn to turn them. Chapter 6. What if this isn't the first time? We've always assumed we're the first to think, the first to dream, the first to look up at the night sky and ask, what's out there? But what if we're not? What if we're just the latest iteration of something? Much older, something that came before, looked up at the same stars, and wondered the same thing. What if another civilization existed before the Big Bang we know, long before our galaxies, our atoms, our time? We think of the Big Bang as the beginning of everything. But maybe it wasn't the beginning of everyone. Maybe consciousness, intelligence, even culture didn't start here. Maybe it started before. It's a radical idea, but not without precedent. If the universe truly cycles, if eons stretch endlessly backward, then there's no reason to believe intelligent life is unique to this one. The laws of physics repeat. The structures of space and time remain consistent. And if conditions align just right in one universe, they could align again. But they also could have aligned before. In that possibility lies a chilling question. What if someone figured it out? What if a civilization advanced far enough, millions or even billions of years, before the birth of our own universe, to understand that everything ends and everything begins again? What would they do with that knowledge? Some might prepare. Some might try to survive the death of their universe. Others might try to leave a message, something that could pass through the reset, a signal, a structure, a warning, not carved into stone or broadcast by radio, but etched into the fabric of space itself, hidden in plain sight, waiting to be discovered. Maybe that's why the early universe looks so strange, why galaxies form too quickly, why black holes are too massive, why stars seem older than they should be. Maybe it's not a mistake. Maybe it's architecture. If a previous civilization wanted to communicate with the next, they wouldn't send language. Language dies. They wouldn't build machines. Machines decay. They'd encode something deeper into the laws of physics themselves, into the constants of nature, into the large-scale structure of the cosmos, or even into the background radiation, the afterglow of creation. And perhaps we've already seen it in the unusual symmetry of the cosmic microwave background, in the peculiar patterns some scientists have labeled anomalies, in those mysterious cold spots Roger Penrose believes are Hawking Point's remnants of ancient black holes from a universe before ours. What if they're not just remnants? What if they're signatures, coordinates, a kind of cosmic graffiti scrawled across time? It's not impossible. In fact, some scientists have already proposed the concept of a pre-Big Bang signal deliberately planted in a way that could survive cosmic inflation and expansion. Some models even suggest it could be done using specific gravitational wave patterns or distortions in the geometry of space-time. If such a message exists, it wouldn't be obvious. It would be subtle, mathematical, encoded into something we might mistake for randomness, until one day someone sees the pattern. And what if someone already has? In 2021, a research paper sparked brief controversy by suggesting that certain alignments in the cosmic microwave background might resemble artificial design. The mainstream quickly dismissed it as pareidolia, seeing patterns where none exist. But the idea didn't fully disappear, because deep down we understand the appeal. We want to believe we're not alone, not just now, but across all time. That intelligence is not an accident, but a property of the universe, a pattern that keeps emerging. If that's true, then what else might be out there waiting to be found? Could the first civilizations of a previous eon have left behind more than signals? Could they have left technology, not in the traditional sense, but structures, so deeply woven into the foundation of the cosmos that we mistake them for nature, self-replicating laws, quantum echoes, triggers embedded in the vacuum of space that only activate when a certain level of complexity is reached. Maybe that's why our universe feels so fine-tuned, why physical constants seem strangely optimized for life. Maybe they were tuned. Maybe someone left instructions that would make the cosmos not just a place, but a message, not just a void, but a memory, not just reborn, but aware. It would mean we are the product, not just of matter and energy, but of intention. The idea is unsettling, because it means everything we do, every discovery, every step forward might be a path someone else already walked. We are not pioneers. We are successors, inheritors of a cosmic legacy so vast it stretches across universes. But it also means we're not alone in our curiosity. Someone else once asked the same questions, looked at the same stars, faced the same silence. Maybe they survived longer than we will. Maybe they saw the end coming and left something behind. Or maybe they're still out there, not physically, but encoded, waiting to be remembered. That changes how we think about time, about meaning, about fate. Because if the universe remembers, if it carries echoes from what came before, then nothing is truly lost. And if life has emerged more than once, has reached intelligence, awareness, even transcendence, then it might again. Maybe that's the lesson, that intelligence is not an exception. It's a phase, a recurring phenomenon in the life of the universe, a flare that burns bright and fades, only to rise again. So when we look at the sky, maybe we're not just looking outward, maybe we're looking inward, into a history that stretches beyond stars, into a story that began long before we were born and may continue long after we're gone. The black holes, the ancient galaxies, the strange radiation, they may all be part of that story. Fragments of a message, symbols in a language we're only beginning to understand. Maybe we're not the first ones to wonder. Maybe we're not the first to ask. Maybe we're just the first to listen, closely enough to realize that someone might have answered long ago, and maybe the universe didn't just begin again. Maybe it remembered. We always thought the Big Bang was the beginning, but maybe it's just one echo in an eternal pattern, and we're part of a cycle far older than time itself. If that's true, then this has all happened before, and it will all happen again. So the next time you look into the night sky, ask yourself, who was here before us, and what did they leave behind?